Hello students, welcome to the class. Here we are going to discuss about electrostatics, charge and properties of charge. Okay, let's proceed. What is electrostatics? The field where we study about the effect caused by the charges at rest is called electrostatics. Okay, where we discuss about the effects created due to charges at rest. Okay, that field is called elect electrostatics. Okay, here we basically study about electric forces, electric fields, and the electric potential. Okay, keep in mind. So here we are talking about charge. What is charge basically? Charge is an intrinsic property of matter due to which the matters produce and experience electrical and magnetic effect. Understood? It is a basic property, basic internal property of matters. There are two types of charges. One is positive, another is negative. Okay. Like charges repel each other and unlike charges attract each other. Like charges means charges of same signs. Okay, they attract, they repel each other. Okay, they repel each other. But unlike charges, that means charges with opposite signs. Okay, they what do they do? They attract each other like this, and like charges repel like this. Okay, now come to unit of charge. SI unit of charge is coulomb. You know that. And the CGS unit of charge is called state coulomb or simply state C, state coulomb. Right? In short, you can write like this. Okay. Or it has another name also, that is electrostatics unit, or shortly ESU. Understood? Keep in mind. The relation between one coulomb and the state. Relation between coulomb and the state coulomb. This is the relation. 1 coulomb is equal to 3 into 10 to the power 9 state coulomb. This is almost approximately 3 into 10 to the power 9 state coulomb. Okay. Or inversely, you can find this value. Just divide 2.998 into 10 to the power 10 to the power 9. Let's see. Okay. In this way, you will get the value. Then come to the dimension. This is the dimensional formula. This is the dimensional expression of charge. Okay, how do you get this? For this, you have to remember one relation, that is electric charge I is equal to charge divided by time. You have to remember this relation. You have to keep this relation in mind. Okay, you will get this relation in current electricity. Okay, in current electricity, you will get this relation, and from here you get the charge in this way. This I is a physical quantity and the time is also a physical quantity. They are fundamental physical quantity, right? So with the help of these two fundamental quantities, we can get the expression of dimensional formula. Okay, this way I t. You can remove this bracket. You can write like this. Okay, understood? So let's proceed to the next one. Properties of charge, or simply, yeah, properties of charge. Yeah. Okay. What is written here? Charge is a scalar quantity and the charges can be added or subtracted algebraically. Okay. Charge has no direction like the vector quantities. Okay, it has only value. That's why it's called scalar quantity. And charges in individual charges in a system can be added or subtracted algebraically, just like adding numbers like this, or like this variable, algebraic variable, right? Like this, you just add them. If there are such charges like this in a system, then the total charges will be like this. Just add them algebraically. Okay. For example, if there are such charges in a system like this, 2q, okay, plus 2q charge minus 4q charge and 3q charge. Suppose this much charges are there in a system. Okay, you just add them. Suppose this is not there. Okay, this much negative charges are there and this much positive charges are there. Then how do you get the total charge? You just add them. Okay, 2 plus 2 charge and minus 4 charge. Then what will be the result? Minus 2 cube charge, total charge. That means minus 2 and plus 2 will be cancelled by each other. Understood? In this way, charges are cancelled. The additional charge is the total charge of the system. It is this additional charge is in minus sign, right? This way you can get the total charge. Okay. Then come to the next one. Charges have mass. Charge cannot exist without mass, although mass can exist without charge. Okay. Charge can must have a mass. Okay. Without mass, charge cannot exist. For example, you can take one example of one atom. In an atom, how many subparticles are there? Three subparticles, right? One is proton, another is electron. One more subparticle is there, that is neutron. Proton, electron, and neutron. Proton has a charge, that is what? Positive charge, right? Whose value is equal to that of an electron. That of, okay, the value of electron. That means the value of charges on proton and electron are same. Okay, just the signs are different. This is plus, this is minus. Okay, but it has no charge. That means this, but they have mass. Okay, they have mass. Neutron has mass, but no charge. That means mass can exist without charge. But suppose if there is no mass of electron, this electron and the proton. Suppose proton and mass have no mass. Okay, then what will happen? They can't exist there. Okay, since they can't exist, their charges will also not exist. Okay, in other words, charge cannot exist without mass. Understood? So let's proceed to the next one. Charge is conserved. Charge can neither be created nor be destroyed. What is written here? Charge is conserved. You can't create a charge, or you can destroy a charge. Okay, charge can neither be created nor be destroyed. Okay, uh, invariance of charge. Invariance of charge. That means the value of a charge doesn't change with the motion. Okay, due to the motion of it. Okay, that means if Suppose the charge of one the value of one charge is q at rest. Okay, and if it moves, then that value will not be changing. While moving also, it will have q charge. Okay, that value will not be changing. Understood? That's why it is invariance. Okay, invariant. It's a charge. It's the value of a charge doesn't vary. Understood? The numerical value of a charge is independent of velocity and acceleration. In other words, it is independent of motion. Okay, understood? Next one, quantization of charge. What's meant by quantization of charge? Quantization of any quantity. When a physical quantity, suppose physical quantity, when a physical quantity have discrete value rather than continuous value, then it is said to be quantized. That means it has discrete value, quantized value. Okay, I mean it is quantized. That means it has discrete value. For example, look at this. Suppose we are going to take a example of number. Okay, up to 2 decimal point. Okay, we are going to start from 1. Okay, after 1, what number will come? 1.01, right? After that 1.0, 1.02. After that 1.03, right? In this way it will get 1.99, then 2.00, 2.01. In this way you'll be getting numbers continuously. Okay, now what's meant by quantization? Quantization means separation. Okay, suppose we are going to separate these two number 1 and 2, 1 and 2. This is the separation. These numbers, the numbers 1 and 2 are separated by this number, right? These numbers. So we are this time we are not getting continuous value. Here we are going one complete separate value, right? These two comes after 1 directly, right? Earlier that two came after 1.99, right? And that 1.99 came after 1.98, like that, right? Continuously the numbers were coming, right? This time this number is directly, it is like jumping. It has like discrete value, separate value, completely separate value, discrete value. Okay, so this is called discrete. Okay, and you have understood this continuous. What is continuous? If a physical quantity have such discrete values like this, okay, then the quantity is said to be quantized. Okay, understood? In the same way of any quantized physical quantity, charge also has quantized, I mean discrete value. Okay, that means charge is also quantized. Okay, so here in nature we get one smallest value of charge. Okay, that is the charge of electron. That is the value of charge of electron. Okay, this is this is the value of, this is the smallest amount of charge found in nature. Okay, and this value is that of electron, one electron. Okay, that is denoted, the value is denoted by small e. The value of charge of an electron is denoted by small e. That means e means equal to 1.6 into 10 to the power minus 19 coulomb. Understood? And since charges are quantized, therefore we will get a total charge in a body as the integer multiple of electron, integer multiple of the value of an electron. Okay, this is the value of an electron. value of charge of an electron. Okay, then total charge in a body will be n this, and this plus minus will come due to the nature of charge. That means if it is positive charge, the sign will be plus. If it is minus charge, the sign will be minus. That means final value, if the nature of the final value will be positive, then this plus sign will be shown put. Okay, for example, I take one example. Suppose one body has a, yeah, I already took that example. What did you get? Plus 2 charge and the minus 3. If suppose one body has this much charge, 2 positive charge and 3 negative charge. Now in this case you can take like this also. 2, yeah, you can take this 2 positive charge, and this positive charge basically what? This positive, one positive charge. What do you mean by one positive A? This is the charge of a proton. Okay, the charge of a proton is positive, and its value is equal to the value of the charge of an electron. Okay, just the signs are different, opposite. Okay, now here in this case, suppose we have two positive charges. I mean proton. Okay, positive charge even. Yeah, 2 E and 3 E. And what will be the value? Oh, suppose this is a 7. Okay, 7. Then total, what will be the total charge? You just add them. Okay, after adding, what will happen? Minus 7E. What will happen? What will be the result? Minus 5E. This 5 is integer. That means total charge is integer multiple of the value of an electron. Okay, or proton. Okay, and this sign comes due to the additional electron. Okay, two to two electron, the value of 2 electrons will be cancelled by the 2 value of 2 proton. The rest 5 electron, the rest will be due to the 5 electrons. Okay, this minus 5 electron. In this way, you get the total charge in the form of integer multiple of the value of an electron. Okay, in this way. Understood? Next one. Yeah, here the charges can't have value like this fractional value or rational value. It can't have fractional value or rational value. Understood? It can have only this integer values. Okay, I mean integer multiple of electron. This n, the value of n should be integer, not like this. 0.5 plus minus 0.5 plus minus 12.8, not like this. Okay, it n can't have the value, can't have value like this. Okay. Okay, next 2 points are there. Although the mass of the proton is about 1800 times greater than that of the electron, their charges have the same magnitude. That means proton has more mass than the mass than electron. Okay, proton has more mass than an electron, and although the proton is greater, proton has more mass, still they have the same amount of electron. Okay, the charges on both particles have the same amount of electron. Okay, one proton and one electron have the same amount of charge. Their signs are different, but value will be same. Okay, and next one, electron itself is not a charge. Yeah, I have mentioned already. Electron is not a particle, a charge. It is a particle. Okay, The value of electron is denoted by this. The value of charge of an electron is denoted by E, small e. Okay, this is the value of charge on an electron. Okay, or a proton. Okay, understood. Let's proceed then. Charge is transferable. Okay, when a charged body is put in contact with an uncharged body, then charges get transferred from charged body to uncharged body. That means, look at this. What I have said here, suppose if this is uncharged body and this is charged body, and they are put together in contact, okay, then what will happen? Charges will flow from charged body to uncharged body, okay, until the total charge on both bodies uh, are in uniformly distributed situation, okay, until they are distributed uniformly on both bodies, okay. So here look at this, and look at the uncharged body. Here I'm assuming that both bodies are identical. That means their shape and the size are same. Okay. Look at this. It has plus two positive charges and two negative charges. That means total charges will be what? Zero. That means it behaves like uncharged. It behaves like there is no charge, right, in that body. Okay. In reality, charge uncharged means it doesn't mean that that it has no charge. It has charge, but it has equal number of positive and a negative charge. Okay, understood. And look at this. Look at the second charged body. Here you get two negative charges. Okay, but seven positive charges are there in the second body. Okay, charged body. So minus two electrons are there, but how many protons are there? Positive charges seven, right? Seven. Yeah. So result is plus 5. This is excess value in positive sign. Okay. Therefore, due to this excess value, it is called positively charged. Okay. More positive charges are there on the body. That's why it is positively charged. And if they are put in contact, what will happen? These positive charges will follow from the charged body to uncharged body. Then the charges will get uniformly distributed. Okay. Once they are distributed uniformly, they are separated. Their charges are transferred. Okay, that's written here. Okay, additionally, I have shown this part. Once they are once the charges are distributed uniformly, then if you uh, separate them, what will happen? You will get this type charges in this form. Okay, that means both will be positively charged. Both will have equal number of positive charge since they are identical bodies. Okay, look at this. Why they are positively charged? Because here you get two negative charge and four positive charge. The ultimate result is two positive charge. That means that's why they are positively charged. Here also you will get plus 2e. Understood? Understood. So let's proceed to the next one. Charges reside on the outer surface of a conductor because like charges repel and try to get as far away as possible from one another and stay at the farthest distance from each other, which is outer surface of the conductor. Understood? What is written here? Suppose this is a conductor. Okay, this is a conductor, and there are many atoms, right? Many atoms, and those atoms have a nucleus. Okay, each atom has one nucleus. Okay, like this you will get many atoms. Okay, in conductors, generally what do you get in an atom? You get a nucleus, one nucleus. Okay, around this nucleus electrons revolve, right, in this way, electron electron electron, like this. Okay, and a proton and neutrons are in the nucleus. Okay, in a conductor, this outermost electrons are loosely bounded. If you give extra energy in the form of heat or other way, okay, if you give extra energy to this atom, what will happen? This electron will go away. Okay, move outward of this atom, and then they will move freely here and there. Okay, in this way, they will be moving freely. Okay, free electrons. In this way there will be many free electrons. Okay, in the conductor. Okay, as a result, what will happen? These electrons will get repelled by each other. They will repel each other. Okay, as a result, what will happen? They will try to stay as far away as possible from each other. Okay, then they will go far away from each other. Suppose this is one electron and this is one electron. They will repel each other. Then this will try to go in this side, Okay, and this will try to go in this side, farthest way. In this way, it will be going. And once this electron gets the surface of the conductor, it will stop there. Okay, it will be moving on the surface like this. In this way, many electrons will be moving on the surface. They will, in other words, they will be residing on the surface of a conductor. Understood? Keep in mind. And this one, when a charged particle is at rest, it produces electric field. That means, suppose if a charge is at rest, okay, this will produce electric field around it. Only electric field. Okay, when a charge it is at rest, then it produces electric field around it. Okay, but if the charge moves, okay, with an uniform velocity, okay, then what happens? It creates electric field as well as magnetic field. Okay, but if it moves with an accelerated motion, okay, it is moving, its velocity is increasing, or it moves with an retarded motion, that means its velocity is decreasing. In this case, what does it do? It produces electric field and magnetic field as well. Okay, along with that, it radiates energy also. Okay, it radiates energy also in the form of electromagnetic wave. Understood? So accelerated or retarded charge creates electric field as well as magnetic fields. Along with that, it radiates energy also. But if the charge moves in an uniform velocity, it creates electric field and magnetic field only. Okay, but if the charge is at rest, it creates only electric field around it. Okay, keep in mind. Come to the next topic, that is comparison of charge and mass. Comparison of charge and mass. Okay, electric charge can be positive, negative, or zero, while mass of a body is a positive quantity. Okay, that means you already came to know that electron can be positive also, negative also, right? Like this, positive also, negative also, or total charge will be, you got total charge sometimes zero. Okay, but mass of a body is a positive quantity. Mass of a body is always a positive quantity. It can't have negative value. Understood? Electric charge is conserved. You came to know. electric charge neither be created nor be destroyed. Okay, you got that. But mass is not conserved. Mass can be converted into energy, and similarly, energy can be created in can be changed to mass. Okay, charge carried by a body doesn't depend upon the velocity of a body. That means the value of a charge doesn't depend on the motion of it. Okay, you got that. But mass of a body increases with its velocity. You'll get this relation. Look at this. This is v is the velocity of mass body. Okay, body with of mass amount m not at rest. When the body is at rest, then its mass is m not. When the body is moving, then it will have this amount of mass. Okay, look at this. If the velocity increases, what will happen? Suppose v is equal to c. This is c is velocity of light. Suppose v is equal to c. Then what will happen? This will be 1 and this will be 1. 1 minus 1 0. This whole value will be 0. M not divided by 0 means infinity, very high. But it was initially when it was at rest, it will be a limited amount, right? But while it will be moving, it will be increasing. Suppose this is v is equal to half of this c. Then what will happen? 1.1 minus something. Okay, that means this value is less than what? 1. If it is less than 1, this whole value will be greater than m naught. Okay, then this will be what? This value will be increasing. That means if a body moves, then its mass is changing. Okay, its mass is changed. Okay, understood. Now come to this. Force between charges can be attractive and repulsive in nature. While the gravitational force between two masses is always attractive, right? You got that like charges repel and unlike charges attract each other, right? You got so that force can be attractive or repulsive, right? But the gravitational force between two bodies or between two masses is always attractive. That means two bodies gets attracted by each other due to their masses. Okay. Due to the masses, two bodies always get attracted by each other. Okay? Each other. Okay. Understood. Understood. And try to remember these values. These are important values. Okay. Charge of an electron this much. This is 9.1 into 9.11 into 10 to the power minus 31 kg. Okay. Neutron has zero mass, zero charge. It has mass only. Okay. 1.6 into 10 to the power minus 19 coulomb. This is 19. Okay. Minus 19 coulomb. Understood? The value is given here. This. Okay. Now let's discuss questions. What is written here? Can two similarly charged bodies attract each other? Initially, what did we get? Like charges repel each other, right? And unlike charges attract each other, right? Here, what is asked about? Can two similarly charged bodies attract each other? The answer is yes, although they have same charges. Why? Every time it is not correct. It should have a special case. That means that special case is that one should be very big. One body should be very big. Suppose both are positively charged. Positively charged means they have the body has negative charge also, but the amount of negative charge is less than the amount of positive charge. Okay, one body should be very big, and the another body should be very small in compared to that. Okay, in compared to the first one. Okay, plus plus minus minus like this. Okay, then if you take such a bodies, one is bigger and another is smaller, very small. What will happen due to the positive charges of the bigger one? What will happen on the smaller one when they are brought nearest to each other, near to each other? What will happen? Charges, negative charges will be induced in this side. That means how many negative charges are there here? Two negative charges. Suppose three negative charges. Then what will happen? Negative charges will be induced in this side, and positive charges will be repelled due to the repelled by these charges. Okay, these positive charges will come to this side, and the negative charges will come to this side. As a result, what will happen? These positive charges and the negative charges will be attracted by each other. So due to that, this body will be dragged by the bigger one, and it will be like minus 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 plus 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 plus. This will be dragged. Okay, they will be attracted. And what will happen? Positive charges of this will go to that side. Okay, charge transfer will happen. Okay, but initially they will be in the smaller body will be attracted by the bigger one. Okay, due to this induced charge. Okay, next, when two identical spheres with charges q1 and q2 touch each other, and after that they are separated, then what will be the value of the charge on each if q2 is positive and negative? That means two cases are given there in the question. One is when the q2 is positive, and another case is when q2 is negative. Okay, case one. That means what is given? Two spheres with charges q1 and q2 respectively are given. Okay, and they are put in contact. Okay, at first touch each other means that they are put in contact. Okay, and what will happen after contact? Charge transfer will happen, right? Then identical, same shape and same size. Then charge transfer will happen, and after that the flow will stop. Okay, then after that what will happen when the flow stops? When the charges get distributed uniformly, right? Here the charges will be distributed uniformly. Okay, at that time the flow will stop. Okay, after that they are separated, these two bodies are separated. Then what will be the value of charge on each body, final charge on each body? In this case, this is q1 is always positive, or it can be negative. Okay, q1 is q1. Okay, but here in case of two conditions are given. One, it is positive. Okay, suppose here in this case we take, you can take negative as negative also, or positive also. Suppose here we are taking this as positive. Okay, and q2 is positive, first case. Okay, what will happen after contact, what will be the amount of charge on each body? Suppose that is denoted by Q. What will happen? How do you get? You just simply add the charges of two bodies, initial charges on two bodies, and divide by 2. In this way, you will get the final value of charge on each body. Okay, this one. Case 2. 1, suppose this is positive, like previous one. Okay, and here in case 2, Q2 is negative. That means they are of opposite signs. Okay, in case of such opposite signs, what will we do? We'll simply do like this. We'll subtract in this way and divide by 2. This will be the final value of charge on its body. Understood? Suppose this is Q, this is Q prime. I have denoted in this way, suppose. Okay. In this way, you will get the values. This is simple. Okay. Next, come to the next question. What is given here? If a sphere 1 with a charge Q touches another uncharged sphere 2 whose radius is half of the radius of 1, then what will be the charges on each of them? That means two spheres are given. One is charged. Okay, charged. Another is uncharged. The charge on the first sphere is Q. Okay, Q is much charge. And then second one is uncharged. And the radius of R2 is equal to the radius twice of the radius of R1. I mean the radius of first sphere. Okay, that means this is given. That means size of sphere 2 is twice that of the first sphere. That means twice 2 times of the size of the first sphere. Okay, size of the first sphere. Okay, understood? Now what will happen? Once they are put in contact, charge will flow from the first sphere to second sphere, and later the charges will get distributed uniformly. Understood? Since since this is 2 times bigger, this first sphere, than that second sphere, hence it will have 2 times more charge than that of the first one or second one. Okay, I mean this. Suppose final charge on first one is Q1 and the final charge on a second sphere is Q2. Then the final charge on sphere 1 will be equal to twice that of Q2. That means charge on second sphere, final charge. Okay, this condition is given. This condition is due to this condition. Okay, understood? Then if you add the final charges, you'll get the previous charge, which is equal to Q. Okay, which is equal to Q. So you get two equations. Solve them, then you will get the value of Q1 and Q2. Okay, what will be the value of Q2? Put the value of Q1 here, then you will get Q by 3. Okay, and what will be the value of Q1? What will be the value of Q1? 2Q by 3, right? In this way, you can find out the final values of the charges on the spheres. Okay, understood? Okay, let's proceed to the next one. Thus, in charging, the mass of a body change. What is the answer? The answer is yes, right? Why? Suppose this is the body and this is being charged. Charging means what? Bringing additional charge, right? A charge has mass. That means you are bringing additional masses. So the final mass of this body will be increased. That means the initial mass of this body will be changed. Okay, while charging. Understood? This is easy. What is written here? Why a third hole in a socket provided for grounding? Grounding means what? Earthing. Grounding means earthing. You have seen earthing at home, right? Why that is done? Why a third hole in a socket provided for grounding? Suppose uh, this is our socket. Okay. Wait. In a socket, how many holes are there? How many holes kept? Generally, three holes kept, right? Like this, and third hole like this. Okay. Okay. So two wires come from electrical current source. Okay, in this way. Suppose this is the meter box. From meter box, you connect in this way. Okay. One is neutral, no current comes, and through another one, current comes. Right? Current keeps flowing. Okay. Current I. Okay. And third one is kept for grounding. Okay. Why is this third hole kept here? That is the question. Okay. Sometimes what happens? Extra charges get accumulated here on the appliances. Suppose in this case we are talking about this appliance, that means socket. Okay. Sometimes what happens? Extra charges get accumulated. Okay, like this, in this way. Okay. Then if you touch the socket, what will happen? Suppose you are going to touch this, then what will happen? You will be shocked due to this extra charge. Okay, this extra charges. Okay, but if this third hole is connected to the ground, what will happen? This extra charges will go to the ground through this wire. Then there will be no extra charge on the appliance. That means on the socket. Okay, then if you touch, you will not be shocked. Okay, due to this purpose, the third hole is put in a socket. Okay, third hole is provided due to this reason. Okay, this way. Understood? Okay, let's proceed to the next one. Yeah, this is easy question. How many electrons are there in 1 coulomb charge? You got one thing. In one electron, what did you get? How many charges? How much charges? How many charges did you get? You got like this, right? 1.6 into 10 to the power minus 19 coulomb in one electron. Right? Now you are asked about how many electrons will be there in 1 coulomb. You simply send this number to that side. In this side you will have 1 coulomb. In that side you will have this much value. Okay, electron. You find out this value, and that will be the result. Okay, this is easy, but you should know this. That's why I have shown this question. Okay, okay. In the next class, we'll learn about point charge and test charge. Okay, so today we'll leave here. Bye.